Imagine looking up at the night sky. So many stars, so many mysteries. One of these stars is called TRAPPIST-1. It's not like our sun, big and yellow. TRAPPIST-1 is much smaller and cooler. It's what we call a red dwarf star. And it's relatively close to us in cosmic terms. Only about 40 light-years away from Earth. That's like a neighbor in our vast galaxy, making it a fascinating target for our telescopes. This special star, TRAPPIST-1, is not alone. It has a family of planets orbiting around it. Scientists have discovered 7 of them so far. This amazing discovery happened in February 2017. It got astronomers all over the world very excited. Why? Because many of these planets are special. They are similar in size to our own Earth. Not giant gas planets, but smaller, rocky worlds. This similarity makes us wonder naturally. Could these worlds be anything like our home? So why all the excitement about this one star system? Well, it's because of the location of the planets in this system. Several of these Earth-sized planets orbit TRAPPIST-1 in a very special region we call the habitable zone. And interestingly, the habitable zone of TRAPPIST-1 system is very similar to our solar system. For a dim star like TRAPPIST-1, the habitable zone is located closer to the star than for the Sun. 3 or 4 planets might be located in the habitable zone. These include E, F, and G, or D, E, and F. This zone is like the sweet spot around a star. It's where temperatures are not too hot and not too cold for liquid water to exist. As of 2017, this is the largest known number of planets within the habitable zone of any known star or star system. If water is there, it could pool on the surface. And liquid water is a key ingredient, we think, for life as we know it to begin and thrive. The news of these 7 worlds sent ripples through the scientific community and beyond. Imagine, 7 Earth-sized candidates for study, all circling a single nearby star. Incredible. This immediately raised a flood of questions. Are these planets truly rocky like Earth or Mars? Do they possess atmospheres, and if so, what kind? And the biggest, most profound question of all, could any of them harbor water, that precious molecule? Or perhaps could they even harbor life itself? The cosmic detective story had truly begun. Water. It seems so simple, H2O. On Earth it's everywhere, in oceans, rivers, clouds. Life on our planet depends on it entirely. Every living thing we know needs water. So when we search for life beyond Earth, out there in the vast darkness between stars, water is one of the very first signs we look for. It's like a beacon, a cosmic invitation, hinting that a world might be habitable, a place where the chemistry of life could spark. But how do we search for water on planets that are trillions upon trillions of miles away? We can't send a probe to scoop up a sample, not yet at least. Our current technology isn't there. So we rely on incredibly powerful telescopes. Giants like the James Webb Space Telescope, or JWST. These telescopes are our eyes on the distant universe. They carefully analyze the light from the TRAPPIST-1 star, especially when that light passes through a planet's atmosphere. If a planet has an atmosphere, of course. Different gases and molecules in an atmosphere absorb specific colors or wavelengths of light. It's like they leave a unique fingerprint on the starlight. Water vapor, the gaseous form of water, has its own distinct signature in that light. Scientists use a technique called spectroscopy to spread the light out, like a rainbow, and look for these telltale signs of water. It's painstaking work, searching for faint clues from worlds so incredibly far away from us. Astronomers also build complex computer models. These are like virtual laboratories for distant planets. They use what we know about physics and chemistry to simulate what these worlds might be like. One recent study, for example, developed a model to estimate outgassing on the TRAPPIST-1 planets. Outgassing is when gases, like water vapor, are released from the interior of a planet, perhaps through volcanic activity, over millions of years. This model helps us guess how much water might be there. Just this month, in May 2025, exciting news emerged. Scientists released new research, a preprint of their study, offering fresh insights into the TRAPPIST-1 planets and their potential to hold that vital ingredient water. This work used a sophisticated outgassing model, the kind we just talked about based on known planets. They compared the TRAPPIST-1 worlds to the rocky planets in our own solar system. Mercury, Venus, Earth, and Mars served as guides, helping to estimate what might be happening far away. What did this detailed modeling suggest? It painted a picture that is complex, yet hopeful. The rate of water outgassing on these exoplanets, the speed at which water vapor might escape their interiors, is likely lower than what we see on Earth. But the possibilities span a very wide range, from as little as 0.03 times Earth's rate to potentially as much as 8 times Earth's rate. The study also looked at magma movement inside, suggesting it might be slow, like on Mars today. So does this mean the TRAPPIST-1 planets are dry? Not necessarily. The research points towards mantles, the layer beneath a planet's crust, its rocky skin, that might be relatively dry compared to some theories. Perhaps more like Earth's mantle water content, which as a percentage of Earth's total mass is small, even though our surface is 71% water. But here's a fascinating twist in the tale. Even with these drier mantles, the study suggests water could still make up to 1% of the total mass of these TRAPPIST-1 planets. Consider this, Earth's surface water, all our oceans, accounts for only about 0.02% of our planet's mass. So, 1% would be a tremendous amount of water, potentially enough for vast, deep global oceans. Meanwhile, the James Webb Space Telescope has been busy. It observed TRAPPIST-1c, one of the inner planets. The findings ruled out a thick, choking carbon dioxide atmosphere, the kind that makes Venus a scorching hellscape. This was a positive sign, suggesting it's not Venus-like. Importantly, these observations did not rule out the presence of water vapor, or even oxygen. Let's revisit that crucial concept, the habitable zone. It's often called the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to potentially exist on a planet's surface. The TRAPPIST-1 system is remarkable because at least 3 or 4 of its 7 known planets orbit within this potentially life-friendly region. This makes them prime targets in our cosmic search. Our search for worlds that might not just have water but perhaps, just perhaps, might also harbor life. These new findings from the May 2025 research add more detail to our understanding of these worlds. They suggest the TRAPPIST-1 planets could be incredibly diverse. Some, if they have that 1% water mass, could indeed be water worlds, completely covered by oceans hundreds or even thousands of miles deep. Others might be more like Mars, barren and dry today. Or perhaps some are truly Earth-like, with a mix of continents and oceans, a dynamic, changing surface. The possibilities remain open, fueling our curiosity. However, there are always challenges in these cosmic tales. TRAPPIST-1, being a red dwarf star, is quite active. These smaller, cooler stars are prone to powerful flares, sudden, intense bursts of X-rays and ultraviolet radiation. This harsh radiation could be bad news for atmospheres. It could strip them away over billions of years, and it can break down water molecules into hydrogen and oxygen, with the lighter hydrogen easily escaping into space. So even if these planets formed with abundant water, retaining it over cosmic timescales is a big question. The great quest for answers is far from over. These latest findings are another piece of the puzzle, a significant clue in this grand cosmic investigation. Future observations will be absolutely essential, especially from our most powerful observatories, like the James Webb Space Telescope and its successors. They will peer deeper into the atmospheres of these distant worlds, searching for definitive signs of water, methane, oxygen, and other biosignatures. The TRAPPIST-1 system remains a beacon of hope in our profound human journey to understand our place and to find out if we are indeed alone in the cosmos.